Hey guys, Matheus Castelo here. I'm an embedded software developer, and today I want to show to you guys what I have been working these last days, right? You can see that there is a demo here running, right? Is a Raspberry Pi, form, some LEDs, buttons, and a DSI screen connected to the Raspberry Pi. But the interesting here is the graphical user interface that I'm using, right? Let me change the page here so you can see that I'm using Slint, right? The Slint user interface framework, but with .NET, right? So I have been working in these bindings through the Slint graphical user interface and .NET, right? So today we can use C# now the .NET ecosystem with Slint to build your graphical user interfaces and applications, right? So if you want to know more, stay with me. Okay, so let's talk a bit about Slint first, right? If you don't know about Slint yet, I really recommend you to take a look, right? They have a very cool graphical user interface framework. The framework is written in Rust, okay? And yeah, it's all open source, is lightweight, right? It is a very lightweight framework. They run in embedded systems, desktop systems, even microcontrolled systems, right? If you have an embedded system that is microcontrolled, also you can run Slint on it. It's very cool. For web, with WebAssembly, and I know that they are working also on mobile platforms. It's not ready yet, but yeah, you can track and see all the development through their GitHub repository, right? They developed the framework on the open on the GitHub repository, right? I will leave here on this video description the link for the Slint website so you can take a look and see how the work that the Slint developers has been doing. This is something that draw my attention, right, about Slint, because yeah, the core is written in Rust, but they already had some bindings for other languages like C++ and JavaScript, right? The JavaScript drawed my attention, right? Because yeah, if there is bindings for JavaScript, for sure it's possible to write something for .NET, for example, right? And Rust and Rust libraries are very easy to use, write libraries and write bindings with FFI support for interop with other processes, with other languages, right? So yeah, this multi-language support is very cool, and I ended up writing the bindings for C#. Okay, but talk is cheap, right? Let me show to you some .NET or some SlintDotnet running, right? Another cool thing about Slint is that they have a very cool support for Visual Studio Code, right? So they have an extension for Visual Studio Code. I already have it installed here, and I will create a project here using the torizon templates, right? So yeah, I already have also this extension here, the torizon IDE extension installed, and I have some templates for the torizon that has already support for SlintDotnet, but is needed to make some modifications on your settings JSON from your Visual Studio Code, right? You have to put these two properties here, the Apollo X templates branch, and point it to the Castelo/labs. So this will get my experimental repository that has the templates for the SlintDotnet, right? And also on the templates tags, we are pointing to the head of the repository, right? So it's getting the latest changes that I'm adding to my branch Castello Labs. Okay, with this we can go here on the Explorer and create a new torizon project. So this will open for us the templates page. Okay, and then we can use here the .NET Slint application, right? So let me choose this one. Let me create a video demo here. Video demo, container name, and I will store it on my temp Visual Studio Code folder. All right. So let's create the project based on the SlintDotnet template, and it's here, right? Let me check for dependencies. Okay, so I have everything to build it locally, right? Okay, so yeah, you can see here that we have .NET C# project here, right? We have the program C#, but also we have this folder here, right? The Y folder. So Slint, the graphical user interface, components, widgets, and everything are defined in .slint files that follows the Slint language, right? So here I have a very simple getting started hello world window, okay? And yeah, with this Slint Visual Studio Code extension, we can use the show preview here, and this will show for us the preview of this definition, right? So what we are seeing here is exactly what have been defined on the Slint file, right? We have an about Slint, some text box, and the horizontal box here with a button, right? So you can see that when I click on the element, we have some border here to highlight the element on the previewer. So yeah, this is a very nice feature. So for example, the font is a bit small, right? So let's put a default font size. Yeah, it's okay. So now it's better to you guys see. All right. So yeah, okay. So this is the Slint file with the Slint language, but we should to have these bindings between properties and callbacks from the Slint file on the C# side, right? So the program CS is a very small file. It's using the top level statement from the .NET C# ecosystem, right? So, but you can see that there is this Slint, the app window, and the new window that the C# analyzer could not be found yet, right? Because we should first build it, because behind the scenes, the SlintDotnet is using the C# source generators to get this window, right? So the window will be generated by the C# source generators. The C# source generator, you get the interpretation of this Slint file, and then we write the window in C# for us, right? So let's build it first. So here on task runner, we have build local. Let's execute the build local. This will .NET build for us, right? You execute .NET build for us. Yeah, all done. And then you can see that now we have everything okay on the C# side, right? The window here is a class that has all the properties and callbacks that we defined on this Slint side. So for example, the counter property here is for a property that is read and written by outside, so we can check here on the program C#. So we have the window instance, and then we can see that we have the counter property on the window instance. Also, the request increase value, that is the callback here. This callback we are using on the clicked event, right? So on the clicked event of this button, right? This button here, yeah, we are calling the request increase value. That is a callback that's being implemented on the C# side, right? So for example, you can see that there is only counter and request increase value. All right, so let's create another one only to show you guys that the C# source generators is working, right? So let's create a new property here. Yeah, the GitHub Copilot is helping me. So I have this new property called value, but we can put, for example, micro hobby. All right, and then now here on the C# side, we should have micro hobby. All right, so the C# source generators generates or interprets the .slint file using the Slint graphical user interface framework, right? Using the API, better say, from the Slint, and then gets it and write for us the window class with these properties and etc. But let's run this application to see if this is working, right? Let me choose here to run and debug. So yeah, here's a template for torizon, right? So there is some options here or entries to you deploy it in a device that is running the torizon core operation system, right? But if you want to try it locally, is also this entry here, the .NET Slint local, right? So you choose this one. Let's put a breakpoint here inside the callback, right? The execution of callback. So let's run it. Okay. Oh, let me close the preview, right? And you can see that the application is already running here. All right, and then when I click this button here, right, the callback for the event clicked should be called. That is the request increase value that's implemented here, and then the Y counter property that is now 42, right, should be increased. Let's see. Let's click. Okay, stop it at breakpoint. The win counter is now 42. All right, let's execute it, and then it's 43. So works, right? It's the C#.NET working together with the Slint Y, and it's very cool. Okay, but I have another demo here, something more advanced. And you guys know, right? A hello world for an embedded device developer is not a hello world without some blinking of LEDs, right? So I developed this another SlintDotnet GPIO Demo, right? So I can open here the app window Slint. Let me show the preview for you guys. So I have a representation of an LED, right? That is an image, right? A toggle button and some pages, right? The LED page with the toggle button and the LED representation, and an about page. So it's a bit more advanced because I'm using the Slint language, components and widgets, and it was very cool. It was very fun to work with this because you can split very well what is the while logic and what should be defined and implemented on the business logic, right? So I found out that was very fun. Okay. And also we have the program C#, right? And on the program C#, what we have is the low-level stuff, right? The GPIO definition. Here I'm using the .NET IoT project, right? I'm defining here the buttons or the GPIOs that I use with buttons and LEDs. Yeah, let me show here the C# project here, because there are some things that is important to highlight. So you can see here that I'm using the .NET IoT project, right? The IoT device bindings and the system device GPIO. So I can have their these cool wrappers and libraries here to access very easy the GPIOs. Also, I have a button here to represent my button, right? I have here the LED and the button, so the same I have on my code, right? And then I'm instantiating the window, the Slint window. On the Slint window, we have the toggle LED callback, right? The toggle LED callback is being called here on GPIO page when we call the toggle LED callback from the GPIO page, right? And also we have, yeah, the win is LED on. This is another property that, yeah, is a Boolean property that we are storing on it the state of our GPIO, right? If it's high or low, so we can change the image of the LED here on the graphical user interface. Okay, yeah, the details. Let's not lose the focus. The details here about the C# project. So you can see that I have these two item groups here. Okay, one is to copy my UI folder to the output of my .NET project, right? When you execute the .NET publish, for example, this you also ship the UI folder, because here we have the Slint files and the images files, right? So the program needs these files because the program you interpreted it again and generates the window for us, okay, using the Slint API. And the most important, this item group here is adding the window, right? The window component, the main window component on the additional files, right? So this is important because the C# source generators is not recommended to use IO commands inside the C# source generators, right? So we do not read the file directly using the C# source generators, and we need to add this file here on the additional files, so the program can read it and then interpret it and get everything that we need to generate the app window class. Okay. Yeah, it's needed only, as I said, the main window, right? The main component that inherits the window that will be our main window for our graphical user interface application. Okay, so let's run this application, right? Let me put a breakpoint here on the win run. Also, I already have here the Raspberry Pi connected through the torizon extension, right? This Raspberry Pi is already running torizon, right? Let me close this. Oops. Let me close these other tabs here. All right. So I can show that I'm running torizon. Yeah, I'm running torizon core 6.3.0 on the Raspberry Pi. Okay. And then as this device is the default one, when we go here on the run and debug and choose Torizon ARM v8, this you deploy and debug the application onto the default device that is the Raspberry Pi. So I can press F5. Okay, let me minimize this. Okay, so all the process will be run for me from the template, right? The template is already set to do the cross compilation, right? To call the .NET publish for Linux ARM 64-bit and package everything in the Docker container, push it to the local Docker registry, and then pull it on the remote device. And then at the end, run the application and attach to the remote debugger, right? Everything is automatically done when you press F5 and have a Torizon, a device running Torizon connected through the station. Okay, it's already onto the debugger. Let me show also the view of the device. It's paused here on the breakpoint. I can continue, and our window, yeah, is there. Okay, so I have our application running, is already running on the Raspberry Pi. So I have two pages, the LED page and the About page, with some images, right, made with SlintDotnet and Torizon image. And I have the LED page with the toggle button, so I can toggle. Oops. I can toggle it, and you can see that when I toggle it, for example, I can, let me show here, on the code, I can put a breakpoint here, and then push the button. Okay, so what is happening here is that we have this button defined on our GPIO page, right? The GPIO LED here. Yeah, it's not GPIO page, it's GPIO LED page, right? So we have here the toggle button, right? On the click event, we have this callback, the toggle LED, and this toggle LED is binding here on GPIO page on our main window, right? And it's calling the callback toggle LED that we are implementing here on the .NET side, right? So I can step by step changing the LED state, writing it to the GPIO. All right, you can see that the LED is already turned on. Okay, and then the representation on the user interface changed when we change this property, the is LED on here. Yeah, this property here, right? So now this is true because we change it on the .NET side, and then this changes the image here for us on the Slint side. Cool, right? But also we have the physical button, right? We have the button connected to the GPIO that does more or less the same, but there is a detail, right? You can see here that I'm calling the win run on Y thread, right? So this is needed because the implementation of .NET GPIO button uses behind the scenes the libgpio and in another thread makes the pulling of the GPIO state, right? So if we change it directly here, the state of the property, this will crash our application because we will try to change something that is not existence, right? It's not existing this thread, right? So we have to sync it and move this action, right? Move this code to run in the same Y from the main Y, from the main Y thread, better say, right? So because of it, we have this on the class, right? This is from the window class, the run on Y thread, and it's valid only after the run, right? So after the run, you can have access and call this run on Y thread and pass an action that this will be executed on the same thread from or Slint UI. Okay, so let's put a breakpoint here. Let's actually press the physical button. All right, so breakpoint reached. So the same thing will be happening, right? Let's change it. Let's write it to the GPIO. You can see that now it's turned off, and then we can execute the run on Y thread. So this will sync our action and will execute on the same thread from our main window, and you can see that's changed. We have the same representation on the image and on the LED. Okay, so I think that's it, right? We have now another option to build graphical user interfaces with the .NET ecosystem. I really hope that the community find it helpful, right, to have this link, and is at least I think that is very modern, right, way to you write your graphical user interfaces applications. You can use top level statement C# directly here, instantiating the window and using it, right? This Slint language is also very modern. You can split the logic from the UI and the business. So yeah, it's very cool, right? But let me also know what you think, right? You think that this will be helpful or not? Let me know here on the comments of this video. I'm also leaving on the video description the links for my social media, right? And yeah, let me know your thoughts about the SlintDotnet. There is something that is needed to implement it yet, right? It's not all the features that are implemented on the bindings, and I really have to know if this is worth it or not to continue this side project, right? More one side project, okay? But thank you very much to stay with me until now, right? I really hope that you like it, this content. Let's put the Y on stress. Also the buttons, you can see, yeah. So you can see that it's working, it's very smooth. I really hope that you like this content, and it's it. See you on the next video.